Okay, Algebra 1, Part 1. This is Unit 8, Day 1. It's all factoring for this unit. Alright, there's lots of different things, different ways to factor. Day 1 is just kind of introduction, get you used to it, some terms and stuff. Alright, some vocab. A lot of these you've heard before, like a product, answer to a multiplication problem. Factors are numbers being multiplied. Alright, quick example, 4 times 5 is 20, you all know that. Factors are 4 and 5, the product is 20. The greatest common factor is what we're going to try to get to today, though, for day 1 anyway. All right, it's the largest number that can go into 2 or more numbers. All right, the front of the notes on day 1, it wants you to find the unknown factor. A lot of the stuff you could do on your own, probably. I'm going to skip to the back of the day 1 notes, where it says, find the greatest common factor. All right, if you get good at this, that's good. It's an easy, once you get good at it, it's going to help you get to the next step of factoring. All right, so let's try this number one. 10 and 45 says find the greatest common factor. Some people can do this in your head. Some people need to write it down. Let's look at all the factors of 10 first. All right, I'm sure you remember doing this back in the day. It's like a factor tree. Factors of 10 are 2 and 5. All right. What are the factors of 45? You could do a separate tree for 45 if you wanted to. All right, or maybe just want to make a list. All right, some people make a list, some people make a tree. It's up to you. Factors of 45. 1, 45. All right. 2 doesn't work. Does 3 go into 45? 3 times 15. All right, you could keep going. 4 doesn't work. 5. 9. All right, anything else for 45? I don't think so. You're looking for the greatest common factor, so it has to be on both lists to be a greatest common factor. All right, so I got a 5 here, I got a 5 here. The greatest common factor between 10 and 45 is 5. So for this whole section, you're finding just the greatest common factor. All right, do a couple more, like between 6 and 14. All right, again, factors of 6, 1 and 6, 2 and 3. All right, factors of 14, 1 and 14, 2 and 7. That's it. So the greatest common factor, it's got to be a 2. All right, you get some of these with variables, x squared and x cubed. Remember, x squared is just x times x. X cubed is x times x times x. How many x's do they have in common? You think of it that way. Right, this one has 2 x's, this one has 2 x's. So your greatest common factor is x squared. It's what they have in common. All right, you get the sum a little more complicated. You're mixing numbers and variables, like number 11 down here. 24a squared b, 18a cubed b to the second. Greatest common factor. Maybe I'll do just the numbers first. Between 24 and 18. Factors of 24. Factors of 18, you're thinking of those, writing them down, hopefully. I know 6 goes into 24. I know 6 goes into 18. All right, you can try something bigger. It's not going to work, I don't believe. All right, we're looking for the greatest common factor. So I think it's going to be 6 for the numbers. Do one variable at a time. If I have a squared, a cubed, well, they both have at least a to the second there. So 6a squared. This one has a b, this one has b squared. They both have at least one b, so 6a squared b is my greatest common factor. All right. You can try the rest of the notes in the homework for day 1. It's not bad. Let's jump to day 2 while we're at it. All right. Day 1 was kind of short. Day 2. All right. You're actually going to factor out the GCF. So some steps. You're going to find the GCF, find what's missing essentially, and then write it as a product. All right. Quick example: 4x minus 8. Look at the entire expression. 4x minus 8, is there a GCF there? Does the term 4x and 8 have a common factor? Well, I know 4 goes into 4x. I know 4 goes into 8. So my greatest common factor is 4. All right, so I'm not going to just write down the greatest common factor. I'm just going to factor that out. We're going to undistribute, essentially. So before beginning this, if I had parentheses here, 4 times what gives me 4x? Well, it's got to be an x. Bring the minus sign down. 4 times what gives me 8? That's got to be a 2. So we're essentially undoing the distribution rule, all right, or distributive property. Let's try a couple examples. 5x minus 5y. Those two terms, do they have a common factor? Well, I got a 5 in both of them. So I can take a 5 out. All right, so 5 times what gives me 5x? That's got to be just x. Bring down to minus 5 times what gives me 5y? It's got to be a y. All right, essentially factoring is distributing, or dividing, I should say, dividing. Try number 2, 7x minus 14. 7 goes into 7, 7 goes into 14. If I divide both of these by 7, all right, I know 7 goes into both of them. 7 is my GCF. What's left though? All right, when I divide 7x by 7, that's just x. When I divide 14 by 7, that's 2. Some people like to think of it as division. That's another way to do it. Let's skip down to one of these more challenging ones. Like number 6. This one has 3 terms in it. So find the greatest common factor all the way across here. 3, 6, and 12. I know 3 goes in all those. There's an x squared, there's an x. There's no x here though, so I cannot take an x out. I can take a 3 out. So my GCF is 3. Factor that out, so I have to write down what's left if I take the 3 out of everything. Take the 3 out of here, I'm left with x squared. Take the 3 out of 6x, so 3 times what gives me 6x? That's got to be 2x. 3 times what gives me back to 12? Got to be a 4. All right, you can always check your work. All right, distribute this back out. You should have the same thing. All right, factoring is just rewriting it differently. It's still the same thing, written differently. All right, they get a little more challenging, but practice will help. Day 2. All right, it's just more and more the same. Try the rest of the notes in the homework.